Hello, this is Richard Brand with Room Ready. I'm doing a series of videos to assist with troubleshooting during AV installations. This video is going to cover serial communication, primarily as used in control of peripheral devices. Let's jump right in with a basic configuration. This is a control device wired directly to a peripheral device, projector, display, camera, etc. It's important to remember that receive goes to transmit when connecting the ports of these devices. The transmit port is for sending information and the receive port is for listening. When the lines are crossed, both devices are sending information into one another's transmit port and their listening ports are never going to get that information. One way you can test this before ever getting remote assistance involved is through a voltmeter or DB9 tester. Firstly, all units involved must have power for this to work. Then, using the 20 volt setting, touch the black needle to the ground wire or cap screw if using the Phoenix block, then put the red needle on the other two pins, screws or wires, one at a time. You should see voltage on both pins, between 4 and 7 volts, depending on the device. If you see voltage on only one of the pins, you may have it wired incorrectly. Try swapping the TX and the RX, then test again. If you swap TX and RX and still do not see voltage on both lines, there is another issue. This could be faulty wiring, a bad device, or a dead COM port. If you take the time to test all of your serial connections, this will eliminate a lot of troubleshooting steps once you get with your CERT technician or programmer. The next slide illustrates the use of an IR port from a control device. When this is the case, the control device only has S or signal and G or ground. Signal is going to be the TX and G will be the ground. There will be no listening port or RX. The only lines you will use from the peripheral device are RX or the listening port and the ground. If documentation for the peripheral device does not identify what line is RX, you can test this with a multimeter. You would test this by finding the line that is not transmitting voltage. This line would be the RX, and this should be connected to the signal port of the control device. The transmitting line from the peripheral would not be used in this scenario. The next slide shows a setup that is a little more complex than the two former examples. In this scenario, serial comms is leaving a control device, entering a transmitter, traveling along a digital media line, exiting a receiver, and finally entering the peripheral device. This is also happening in reverse from the peripheral device back to the controller. For troubleshooting purposes, you should treat both ends separately, meaning you should test both sides to make sure you are getting voltage on TX and RX. The control side should be the easier of the two to connect correctly. Generally, TX and RX are labeled on both the control device and the transmit device. So you just connect TX on the control device to the RX on the transmitter, and then the RX on the control device to the TX on the transmitter. When serial communication isn't working, the issue usually is on the peripheral device side, as this device is a DB9, 3.5, or some other connection that doesn't normally have a pin out or reference for TX and RX. It is easy to determine the pin out by using your voltmeter. By using this method, you can find the line that is outputting voltage and be confident that this is the TX of the peripheral device. This line then goes to the listening port, or RX, of the receiver. The final scenario is the loopback test. When we run into a problem, maybe you have tested the line with a multimeter and have gone down every troubleshooting avenue you can think of, but we still can't establish connectivity. This can test whether or not the command is leaving and then finally returning to the controller from the very end of the chain right back to the initial COM port. The command goes out the TX port and then comes right back in the RX port. In closing, a multimeter is a great tool for testing serial communication. If you aren't familiar with how to use one, I suggest getting familiar, at least with this limited use of the multimeter. There are other devices out there such as the DB9 tester. These devices are much smaller than a multimeter, so they take up less space in your tool bag. However, they are limited in their uses since they work for DB9 only. Also, USB to DB9 cables are not analog DB9 cables and can't be cut in half to use the DB9 connector. These are digital USB cables, and 3 wires inside are not pins 2, 3, and 5. There are specific USB to analog Phoenix cables, but the run-of-the-mill USB to DB9 cables are not made for that purpose. Poof. Finally, it is important to remember that serial communication is not magic. It uses a series of electrical impulses transmitting from one device to another. This is why it is easy to track with a multimeter. The listening port will not send out voltage, while the talking port will. If you remember this, you can use logic to connect all of your devices and never get it wrong.